Hello, this is Mrs. Huntley. We are in Module 4. We're using the supplemental packet that has linear relationships on the front cover. Please get your packet out and open to lesson number 8. Add the essential question at the top. How do I compare linear relationships? Your page should look like mine in the top left-hand corner. It should say linear relationships, student handout number 8. And the title is Comparing Linear Relationships. So using what we know about slope and rate of change, practice comparing linear relationships in the following examples. So two runners are competing in a race. Runner number 1, his information is in this table. X is on the top, Y is on the bottom. Runner number 2, his pace is being represented by this equation. X is the number of miles, Y is the number of minutes. So the number of minutes is this slope times the number of miles. What this means, I'm going to start with runner number 2. What this means is runner number 2 is running at a rate of 9.5 minutes per mile. For runner number 1, I've got to calculate the slope to know what they're running per mile. So I can use my Larkin L, or those of you that like using the slope formula, you could use the slope formula too. So I'm going to use the first point, 2, and 18.5, and then 4 and 37. And I'm going to subtract down. I'm going to grab my calculator and I'm going to plug in 18.5 minus 37. Please do it together with me. And I got negative 18.5. And then 2 minus 4 is going to be a negative 2. So I'm going to take negative 18.5 divided by negative 2, and I'm going to get 9.25. And I know, I told you to leave it as a fraction, and ordinarily I'd say yes, leave it as a fraction. But being that runner 2 is in a decimal form, I want to compare these two. I want to be able to look at them side by side and figure out which one is larger and which one is smaller. Now they're running a race. So if I say runner 1 is running 9.25, it's taking her 9.25 minutes per mile, and runner 2 is 9.5 minutes per mile, who's running faster? Okay. Runner 1 is running each mile in 9.25 minutes. It takes runner 2 9.5 minutes to run each mile. So although 9.25 is a lower number than 9.5, it's a race. So we want the mile to be run in a shorter amount of time. So that's why in this one we're ordering from smallest to largest to get the one that's going faster. Usually when we're talking about a greater speed or something greater, we're going to be ordering from greater to smaller. But you just have to compare the relationship in whatever we're talking about. And we are comparing the slopes. Guys, remember early on I told you slope, rate of change, unit rate, all of those things are synonyms. Now, we could have, if I had seen here, and I guess I should have done this, at 0 miles, or at 0 minutes, we would have run 0 miles. So I know that this is a proportional relationship, and I could have, to calculate my unit rate, I could have just taken my minutes, my y, and divided by my x, and I would have gotten 9.25 as well. But it never hurts to be practicing how to find the slope of 2 points, does it? We need to know that, so. All right, the next scenario. The Smiths and the Johnsons are both driving to family vacations for winter break. So the Smiths family, this is our equation that represents the number of hours is equal to 58 times x. So in 1 hour, they're going 58 miles, right? So we're traveling at a rate of 58 miles per hour. So I'm just going to say our rate, 58 miles per hour. Looking at the table, let's figure this out. So it's going up by, let's see, 50s. So if I go up 1, 50, and over, this would be 50 over 1, or 50 miles per hour. Okay, so which family is traveling at a greater speed? Explain your reasoning. Hopefully by now you've picked the Smith family, right? We picked the Smith family. Explain my reasoning. The Smith family is traveling at 58 miles per hour, while the Johnson family is traveling at 50 miles per hour. This is a faster rate. I'm ordering from largest to smallest here. Bennett and Jarrett are both saving money to buy new dirt bikes. Bennett's account. At 0 weeks, he's starting with $115. So this is one where I can't do simple division to figure out the rate. I've got to do the slope L to figure out the rate of change between several different points, okay? Because he's starting out with a lot of money, whereas Jarrett is starting out week 0, he's got $0. So it's going to take Jarrett a longer period of time to save the same amount of money because he's not starting out with $115. He's not starting his graph up here. Okay, so let's take this step by step. Let's figure out Bennett's rate of change. Let's figure out the slope for Bennett's account. So again, I'm going to use my Larkin L. And again, if you are more comfortable using the slope formula, I'm going to write the slope formula up here. If you'd rather do that, you are welcome to. But it seems that students make mistakes when they're using the slope formula. But again, I don't care what you use as long as you're getting there. Okay, so I'm just going to pick the first two, I think. 0 and 115, and then 1 and 163. I'm going to plug in my calculator. 115 minus 163. Please be doing that with me. And I get negative 48. 0 minus negative 1, or 0 minus 1 is negative 1. So negative 48 divided by negative 1 is going to be a positive 48. So Bennett is saving $48 per week. Let's see what Jarrett's doing. Let's see. So this is counting by 25. So there's 25, 50, and there's per 1 week. So Jarrett's saving $50 per week. Say, who is saving money at a greater rate? Explain your reasoning. So $48 per week is less than $50 per week. So Jarrett is actually saving money at a faster rate. But I'm thinking Bennett is probably going to reach his goal faster because although he's not saving as much money each week, he's starting off with a lot more money. So I don't know how much he needs for his dirt bike, but let's just say they need $300 for their dirt bike. Bennett's going to get there in 4 weeks, and it's going to take Jarrett more than 5 weeks to get there. I just want you to be able to interpret this graph. It's actually going to take Jarrett, what is it going to take him? He's saving $50 a week. It's going to take him 6 weeks to get there because I'd need another week to be at 300. And that's just a guess that that's what he would need. But that's not what the question was asking us. I just wanted you to be able to see that when you're starting off not at 0, Bennett might get to his goal faster even though he's saving at a slower pace. The question was asking who's saving money at a greater rate. This is your rate. So this, 50 is bigger than 48. So that's why we're picking Jarrett here. Okay, Lauren and Sean are skydiving. Lauren's elevation. Now be careful here. This is not in slope-intercept form. Well, it is in slope-intercept form, but the x term usually comes after the equal sign, but it doesn't. I could rewrite this equation and be more in the way that we're used to saying it. So y equals negative 172x plus 13,000. So they're starting at 13,000 feet and they're jumping out of an airplane, and she's dropping at the rate of 172 feet per second. Okay, so that would be 172 feet per second that she's dropping, or descending, I guess you'd say. So she's descending at 172 feet per second. Now we have to figure out what Sean is doing here. So again, I'm going to use the Larkin L to figure out what the slope or rate of change is in this scenario. I'm actually going to take this point, 2 and 12,150. I'm going to put that one first, and then I'm going to do 0 and 12,500. 2 minus 0 is 2. 12,150 minus 12,500 is negative 350. Negative 350 divided by 2 is negative 175. So I'm looking at 175. Well, he's dropping at negative 175. That's 175 feet per second. So who is descending at a greater rate? Which one is more negative? Sean's would be more negative, 175 feet per second, while Lauren is descending at 172 feet per second. That's a little too long, isn't it? There we go. Does that make sense? Okay. So I'm going to summarize today's lesson a little bit for you. Please don't copy down what I'm writing word for word. This is just, we've gone over this a couple of times, and I want to make sure you're understanding. Slope, rate of change, unit rate, all are synonyms. To compare 2 or more scenarios, identify the slopes and compare them. Depending on the situation, you might be looking to order the slopes from greatest to least, or like the first example, you might be ordering from least to greatest. You've got to figure out what the question is asking you and answer the question. Okay? So I hope that this was not confusing to you, and if it is confusing, if anything in this lesson is not making sense to you, please write down a specific question. Identify what's not making sense. Again, I don't get it, or it doesn't make sense. It's not a question. I can't really answer that, and I want to be able to answer your questions. I want this to be clear for you, okay? So please write down any questions that you have, bring them to class tomorrow. We are doing an interactive activity tomorrow, and hopefully you're going to enjoy it, and it's going to solidify this learning for you. Have a great night.